Hey guys, in this video, we're going to talk about circle graphs. Let's read the definition. It says, circle graphs, which are also known as pie charts, are pictorial representations of percents. So the entire circle represents 100% or a whole, right? But there is a difference though. In percent, we have 100, right? 100 little pieces. In the circle is divided into 360 little pieces that are called degrees, okay? So our whole, or 100%, is 360 degrees. It's sort of like different unit systems that we already talked about, like kilos in one system and then pounds in another system. So here we have a system where we have percentages, and we have another system that has 360 degrees for the same thing, for the whole thing, okay? But so a thing to keep in mind is that 50% would be half of a whole, right? It's half of 100%. And so half of 360 would be 180 degrees. All right, so let's take a look at this example. It says a florist sells 5 different colors of roses in the weeks before Valentine's Day. The pie chart below shows percentages of the roses sold in each color. Question A, what percent of the roses are orange? Okay, and so if we look at this chart, remember, I always tell you, there could be only one unknown that we can solve for, right? In one equation or one situation. So when we look at this pie chart, we know the percentage for red roses, pink roses, and yellow roses, but there are actually 2 unknowns, right? For orange and white. But we could, knowing the fact that half the circle is only 50%, or 180 degrees always, if we cover this half, then we know that this is 50%, right? And in that part, there are only 3 portions, right? And we know the quantity for each one. So 25, 12, and X percent. So that's how we're going to set up our equation. We're going to say that 25% plus 12% plus X percent is going to give us 50%, or half of a circle. So, and this is our equation that we're going to solve. So we're going to simplify the left side. We're going to add 25 and 12 like terms, right? So it's going to give us 37. So we have 37% plus X percent gives us 50%. And now the next step is to subtract 37% on both sides. 37% on both sides. And we're going to have X percent equals 13%. So X equals 13. So that's going to be our answer. And I'm not going to write it here because I don't have enough room for writing out my answer. But basically, if I did have room, I would write there are 13% of roses that are orange. that was sold on this in the weeks before Valentine's Day. All right, so let's take a look at question B. Question B says, given that there are 252 yellow roses, how many roses are there altogether? Okay, so remember our proportion, right? We have amount to the whole equals percentage to 100%, right? So let's figure it out. What are we given here? So we know that there are 252 yellow roses. That's not the whole, right? That's the number. All right. So 252, or the amount. So that goes in the place of the amount, right? The question is, and my fault, we always start with identifying the X, right? Our variable X. And that's how many roses are there all together. So that's our X value right there. And that's the whole, right? That goes below 252. So here we need to write the percentage for yellow roses. Where do we get that? Well, we can read it from the chart. The chart tells us that there's 12% of yellow roses. So we put 12% there. Okay, so we will proceed solving this equation as usual, cross multiplying. So 12%. And okay, the good polite way of solving this equation is converting our percentages into decimal form instead of, keep writing percentages. So 12% is basically 12 divided by 100 is going to be 0.12. And then I'm going to multiply by X equals 252. And then again, converting 100% into a decimal, it's always going to be 1 because it's 100 divided by 100. So that's 1. 100% in decimal form is 1, always. So let's just keep it like that. So basically we can ignore that 1 for now because 252 times 1 is 252. So in order to save space, I would normally just copy this line without the 1 there, but because there's so not enough room here, I'm just gonna ignore it, pretend that it's not there. So, and I'm gonna divide both sides by 0.12 because I need to solve for X. Okay, so the factor of 0.12 cancels out and we have X equals, it equals to 2100. So 2100 is the value of our X, which answers the question, how many roses are there all together? So my whole, or how many roses are there all together, equals to 2100. All right, let's move on to question C. Says, what is the ratio of the number of white roses to the number of red roses? All right, so I'm going to show you 2 ways to do it. So the first way is to basically figure out the quantity for each type of rose. So for white roses, well, first of all, we have to figure out the percentage of white roses, right? So the percentage of white roses, let's make it the variable W, the percentage of white roses. So the percentage, let's say white roses in percent equals, we know that the whole thing is 50%. 40 of them is red. So 40%, I mean 50 minus 40, but okay, let me go back. So 50% is composed of or equals to the percentage of white roses plus the percentage of red roses, which is, we don't know W, but we know percentage of red roses, 40. Now subtracting 40 on both sides, we get 10% on the left, and that equals a percentage of white roses. Okay. Now, next, we need to find out the actual value for each. So, and we could set up a ratio for it and solve it, but I'm gonna take a shortcut and use one of the formulas that we looked at. So the number of red roses equals the percentage in decimal form, which is 0.4, times the total number, which is 252. Sorry, not 252, 2100. So 2100. Sorry for the mess. Which gives me 840 red roses. In the same way, I'm gonna find the quantity for the white roses. We found that there is 10% of white roses, right? 10%. So 10% in decimal form multiplied by 2100 will be 210. By the way, when you're solving these types of equations, remember in the class we were doing proportions, and we could write percentage as percentages. We didn't have to convert. But if you use one of those formulas, you have to convert your percentages into decimal form. Okay, so the ratio of the number of white, so they want white to red. That's gonna be 210 to 840. Okay, now I can tell that I can simplify that fraction. Well, obviously there is a factor of 10 there, but there could be also a factor of 3. In fact, I think I clearly see that 3 is also a factor. So let's simplify this ratio. In fact, 210 goes into 840 4 times. So the simplified ratio will be 1 to 4. Now, I want you to look at those percentages. So for white roses, we found 10%. And for the red roses, 40%. So if we were to write that ratio using percents, that would be 10 to 40, or 1:4, same ratio as here. So the takeaway here is that if you know percentages and you're asked to find the ratios, you can use percentages totally. Or if you knew the degrees for these angles, you could use those as well instead of the actual quantities. Okay, so here you go. For calculating ratios, you may use percents or percentages instead of the actual quantities here. So instead of 210 and 840, you could use 10 and 40.